รวมเลย
Okay, good morning everybody. So, can we take our seats? Orawan, to come up here please, who's arranged the visit, and Perisak, also just to come, and I'd like to say thank you to our two colleagues who have worked very hard to make all the arrangements here. So,
Say something? Welcome to our campus. Sorry that it's rained probably all day today. So to go to the field will be very difficult. But welcome you all to the campus again. Hope you enjoy staying with us all day, and we try to do our best to get you enjoy day to day. Thank you.
Good morning. Welcome also. And just briefly, Kasetsart has 6 campuses. Kasetsart University. This is the second campus, and we have around 4,000 students only. It's agriculture campus, you can say that. The area is around 1,200 hectares, this campus. And if we cannot go to the field, maybe we can still stay in the bus, and we should have a chance to look around the campus. We are here 4 or 5 staff. Also will be here in your expense. If you want to do anything and you want anything add on, we'll be happy to serve you. Again, welcome. Have a nice day, although it's raining outside.
Okay, well, thank you very much for arranging. I've been a friend to Perisak for more than a dozen years, and I met Dr. Orawan early this year. So we appreciate very much all the arrangements they made. And well, you can all pray while we're talking that the rain will miraculously stop. And I suggest during the field visits, arranging to drive the bus to the side of the field, and also there's a glass house with GM plants, and those who wish to venture from the bus, depending on the rain at that time, can do so with umbrellas. And in fact, the GM Papaya field, we cannot go outside into the field. We could only walk along the fence. So the bus can drive along the fence, and you can go out to take photos if you want or something. And the other agricultural institute is similar arrangement. So they've also worked hard to prepare posters to display their work, and they'll have introductions. And we will split into 2 after lunch as planned, just so it becomes an easy size of people, so that we have half doing one GM papayas first, and then half going to the ABRDC. Okay? And then they swap visits. So I'd like to start. We wanted to have some introduction to the GM papaya work and research here. So I'd like to invite Kanakwan Romiano to talk about GM papaya for DRSV resistance. And I'd like if the speakers could give us some background as they introduce themselves. Thank you.
Good morning again, everybody. The first topic that I would give is about the production or how to use the genetic engineering technology to produce transgenic papaya resistant to papaya ring spot virus. So let me give you an introduction of the plant that we use, or is a case study for using the genetic engineering technology to for crop improvement. Papaya, as we know, is the member in Caricaceae family, and it's tree-like herbs, and it's originated from South American or mainly southern Mexico through Argentina and Chile. And what the impact or the importance of papaya in Thailand is because one of our favorite dish, which is papaya salad, is people like it and have it in every meal. And the varieties of papaya that we use to or like it is the khek dam and khek nuan. The difference is between these two cultivars is khek dam we used to have it like a ripened fruit for salad, and khek nuan is to use for this kind of dish is called som tam. It's contain low calorie, and because of chili and lemons and tomato makes it a kind like a good dish for everyone in Thailand. And the major constraint or the problem for papaya cultivation is the spreading of the disease. We call it papaya ring spot virus, and the symptom, like the name of this is they will make a ring spot or streak on the stem of the plant, or on the leaf they will show mosaic symptom, and the leaf shape will change, and the plant will die after 1 or 2 seasons. And the causative agent is papaya ring spot virus. Let me give you an introduction or brief introduction of this virus. It is the family of RNA virus, which is potivirus, and it can be transmitted through the aphid, which is very, very small insect. And this is the symptom of plant when they get, or when the virus spreading to the field of papaya, and you cannot get any fruit, or the yield of papaya will reduce significantly after virus infection. And this show you the the ring spot symptom on the fruit. And this kind of fruit, it will change the flavor or texture of the fruit as well. So even you can get 1 or 2 fruit from the plant, it cannot be sold out because it will not be good anymore. And for the disease, we for the control by natural cultivar or white papaya that you cannot get natural resistance in papaya for papaya ring spot disease because the papaya cultivar that have resistance is a wild type, and you cannot cross to the cultivated cultivar. So that does mean that you cannot use the conventional breeding to make the papaya ring spot disease resistant papaya. And for other control, we have another technique called cross protection, which has been developed by Dr. Vichai, and he will give you more information later on. That we use it's like a immune. We use a mice strain to make the protection by use like a vaccine, but by using the mild strain of PRSV and put to the plantlet, and they will have resistance to virus, but it costs you like a labeling cost. You have to make a lot of plant and use it's not inheritable to their progenies. So it may not be good technique to control this disease. And because I told you before that it can be transmitted by aphid, so the vector control is is ineffective, or you have to use the other chemicals to control very heavily to this kind of insect. And the most favorite of method to control this disease is to cut it down or take it off to the field, because it will be the it's the kind of inoculum size for other crop as well. So we turn to the technique that we use, the genetically modified papaya, which has successful application in Hawaii, Taiwan, and Australia by using the code protein genes of the virus and put into the papaya genome, and they will show the PRSV resistant in the transgenic papaya. So in our case, for production of transgenic papaya for PRSV resistant, first we will develop the Thai varieties of papaya which contain PRSV genes that show resistance to PRSV. And the second one is to screen or whatever we like, we obtain from the transformation, we will screen for their resistance to PRSV. And this is to show you the, we use CP and NIB, which is the gene of PRSV itself, and make the construct or like a machine that you can put into a papaya genome. But these two genes has been proved that it's work, and it will give you the resistance to PRSV. So first of all, we have to start by doing the tissue culture of papaya. We excite or we cut the immature zygotic embryo from the young fruit and culture it in a liquid medium for 3 months, and this will give you the somatic embryo as a target tissue for starting transformation. And this is the machine that we use to deliver the gene of PRSV into the papaya genome by using the particle gun. So this machine, by using the helium gas as a gas carrier, and you use the gold particle as a bullet, code with the gene that you want to put in the papaya genome, and you place your tissue culture here, and doing it in vacuum condition. In this method, the gene that you want will be delivered into the papaya genome. And after that, you have to select them in the medium that contain selective agent, which is like scanamycin, to select the transform tissue or embryo that has been or contain your gene of interest. So this will show you the result after tissue transformation, after regeneration. We get plant or transgenic papaya, and you inoculate the PRSV, the virus that causes ring spot disease, into both. This is a non-transformed plant compared to transformed plant, which show resistance to PRSV. And the strain of PRSV that you use is a Chiang Mai or even other isolate that you can pick up throughout Thailand. So this shows you the resistant performance compared to this one that heavily infect with PRSV and show the symptom after 14 days. And other step, we have to move to see their performance or their agronomic characteristic in greenhouse or screenhouse. So this kind of screenhouse, it's made by 32 mesh net nylon. So to protect the pollen or insect come in and all come out to this kind of screenhouse. And this picture shows you the Transgenic papaya, which we have screened them for PRSV resistant and want to have a look others for their agronomic characters. And this is the typical cagnon or the original cultivars that we use for transformation. It's have a elongated shape, which is normal, and this is one of the lines that show resistance to PRSV. The character of them is similar to their parental type, and some of them, or KN49, we have other shapes like it's like an oval type, which is different from parental type, but it's quite interesting to have them and to breed them along or between the lines that we have. So this kind of result show you that we have to screen them as well for the set type. Papaya have 3 types of flowers: male, female, and hermaphrodite. And hermaphrodite will get you the elongated fruit or the long fruit, which is quite important for papaya that go to the industry or go to the factory, because it contains you a lot of seed, and the fruit shape or the character is desirable for the canning industry. And some of them show one band it means that you got female plant, which is you don't want it. And if you got 2 bands for your plant, that means you get hermaphrodite plant. So you have to select this and continue for breeding program as well. So this show you that we have the patterns of gene of PRSV to use in the production of transgenic papaya. Use CP, which is called from coating code protein of PRSV, or NIB, which is the replicate the gene that need to replicate the genome of virus. Or we decide to use delta CP, which is what you arrange your CP and another CP in invert orientation, and see the difference of gene that you can arrange or use will give you the different resistance to PRSV as well. This means that if you release this kind of plant that have CP and the virus can resist to this kind of transgenic papaya, you will have another pattern of the gene that can handle virus spreading, or in the future if the virus can outbreak of the virus. So you have to make other gene arrangement or the different construct to take care when the virus is like we have an outbreak, or we can't control virus by only one pattern of the gene. And this is the summary of what we will do other in the future. Or we will start by first using that the screened line or the line that shows PRSV resistance to initiate the breeding program and to confirm the resistance in R1 line, so in the next generation, and to see the biosafety evaluation in greenhouse, which is Dr. Vishai will talk to you later. So this is the summarize of how we produce transgenic papaya that resistant to PRSV. So let me call Dr. Parisha to give you another example of a transgenic papaya in another approach.
Thank you. So I think Dr. Perishak will talk, and then we have questions for both of you together. So, okay, so Dr. Perishak, please come up, and then both of you come back to the questions. Thank you very much.
Okay, I think, again, good morning for everyone. I'm supposed to give a background on myself. So my background is microbiologist. I got my PhD in molecular biology at Queensland in QUT, Brisbane. Okay, so what I'm going to talk to you about, I just follow the name from your programs. It's about the delay ripening. What I'd like to emphasize here is that papaya is not just your ordinary backyard. Okay, what I want to emphasize to everyone here is that papaya is not your ordinary backyard plant. You can use it for so many things. This is just example of the application that you can get from papaya. You can get sort of leaves. You can actually eat them. I heard someone say that it got anti-cancer properties, but that's need to be further explored, or latex for your digestive aids and hair removal and cosmetics and everything. So it actually has a lot of values in itself, not just as fruit or just vegetable. And you can see that it comes from every part of the plant. And this slide is just to show you what we usually do. I have to say in Thailand, because in other countries they have a better approach to handle the papaya fruit. Usually in Thailand we harvest them, and then you put them, throw them in the truck, and it go into the retailer, or some of the fruit lucky enough to go to the supermarket. So when you see these slides, the information you get is that it's going to bruise, it's going to get lost. You wouldn't get very much at the end of the line. And sure enough, you get fungal infection, you get bruises, and at the end of the day, it got shorter shelf life. And as a lot of you probably have same experience as me, is that the flavors and the color development of papaya is terrible, because just to avoid all these problems, they picked it up early. So what can we do about that, or what caused them? We found that mostly it caused by the fast ripening character of papaya fruit. So quickly we go into the factor that influence the ripening in papaya, which is actually mooning, temperatures, and internal factors. And what we're going to do about that, there's several different ways. As I would like to emphasize here that we don't have to do the genetically modified for papaya, but it is a sort of a good way, especially for Thailand, because as you see that in other solutions, good harvest, good packaging, temperature control, waxing, and all that, it actually increased the cost. And if you go back to this slide, you can see that it's not going to happen, or only in some cases. So it leaves us that delay ripening with the genetically modification is a good alternative way. And at the end of the day, when situation improve, we can use the combined method, which is you even increase the value of the fruit itself. Okay, so what's the process that we're doing? First, we select the varieties, we do the transformation, we generate and select them, we determine the characters, which generate progeny and biosafety protocol. As you see these slides, it is similar to what Dr. Kanokwan already showed, so I will not go into the detail how we did it because it's very similar. But I can tell you that before we did the experiment, we have to actually study the property of the gene itself before we use it. So we actually done a lot of work on the molecular biology side of the gene itself before we actually transform into the plant. And as it goes further, you get the root and acclimatize and grow enough and it be in the greenhouse. So what we're looking for? We're looking for the papaya that have reduction in ethylene production, increase in shelf life, total soluble solid shouldn't change very much, and got desirable shape. What it means is that it still have the cylindrical shape, and hopefully low copy number of transgene. I give you 2 examples of transgenic line that we have. You can see that it's got longer shelf life, reduction in ethylene production is sort of about 50%. The breaks is the unit to measure the total soluble solid, which is in the common term is the sweetness, which is just about right. Got 1 copy number. So it's great. So what we are doing now is that we generate progeny. This slide that I show you, it's from the R0. So at the moment we're doing the R2, but only for the PDB90 because we have the restraint on the area to grow them. Because for the delay ripening papaya, we have to grow them only in the greenhouse. So you can imagine the size of the papaya and the size of the greenhouse. So you wouldn't have too many papaya in the greenhouse. So that's what we're up to at the moment. And just to show this slide, this is one of my favorite photographs because it's got papaya in the middle among all those expensive fruit. So it got potential there. Thank you.
Thank you. And then also please come back. Can I please come back? And we have some questions. So let's take some questions. If you have questions, then Morgan, please use the microphone.
Just down south of Kuala Lumpur, Malaysia. I'm a geneticist, so I hope that this district will also give me some material with which to use in my teaching program. I was interested in the delayed ripening, and I couldn't see very clearly which gene you were targeting for delayed ripening. Could you maybe tell us which one it was and whether or not it was? Did you do anything to the promoter, or was it some other mechanism?
Okay.
Thank you.
We were using the ACC oxidase, but there was a few ACC oxidase gene papaya, so we select the one that actually activate or express during the ripening. As for the promoter, for this experiment, it still use 35S, but we also working with the ACO promoter. Thanks.
Okay, Morgan, next please, and then I'll go to Nianco and Alvin.
Morgan Pollard, environmental scientist from Australia. I've got a general question and a specific question. The general question is, what's your philosophy on the ecological principle of maximising biodiversity? And for example, do you think that the out-of-control ring spot disease might be an artefact of growing papaya in a monoculture rather than a permaculture or polyculture? And a related specific question is, you mentioned that your background was in microbiology. Does this institute also employ people with understanding of macrobiology, in other words, ecologists?
Okay, first question first. about the cultivation of papaya in Thailand, I have to emphasize in Thailand because you can't say for someone else. In Thailand, I don't think they grow papaya in large number, for example, compared with Australia. Okay, that's first. Second is that papaya, as you already heard from the second one, is not native to Thailand. So, as you say, it's introduced, already introduced, it introduced plant, okay? And as about the PRSV, you probably heard a lot of people talking about PRSV, but one thing is that PRSV actually has so many hosts. It also infects cucumber, infects pumpkins. There is actually 2 strains of PRSV which we didn't talk about today. So it is not just because of papaya. I actually have another idea that it probably because of other plants. Because in Thailand you mix culture them. You have papaya, but you also have cucumber maybe on the bottom. So I think it's the other way around. As for my background and ecology, okay, I think that ecology probably the main concern for us. That's why it didn't go out, because we're so concerned about them and what's going to happen after that. Because I believe that when you allow Transgenic to go out, it's probably very hard to control them. So that's why we're still investigating what's the best possible way to do these things.
Thank you.
I would like to ask you a question, Gupta from India. That is, you are selecting the PRSV resistant gene. Are you getting them from wild varieties of papaya? That's the first question. Second, are you still in the field trial stage, and what is your next plan?
All right. You mean the strain of virus that we use to screen? We use the virus strain that we collect throughout Thailand, like all in the major cultivation of papaya area. So everywhere that have variety spreading, we go and collect them and have in the collection, in our collection, and to screen or to determine that this line resistant to PRSV, we inoculate them to all of PRSV strain in Thailand. And is this answer your question? And for the gene of PRSV, we compare the sequence of the viral genome and see which one will be we use the gene from Chiang Mai isolate, which when we compare the homology of the gene of virus in Thailand, we can use it like a target gene to make it resistant to PRSV in Transgenic papaya.
I'm Miyako Bada Kakaki and come from Japan. I'd like to know the GM fruits which were accepted by the Thai people, because in Japan, for example, tofu made by the GM soybeans, they don't like to buy it. So the company put in a package that tofu was not made by the GM soybeans. They put that and they buy it. Something like that is happening in Japan. So I don't know. Even you make the GM fruits, will be accepted to the Thai people or not? I'd like to know.
As you probably know, that people perception change all the time, and there's this. First, there's no vaccine or no other way to control PRSV. What they're doing now, we keep moving where they grow the plant, moving and moving. So at the end of the day, there's no way to run. Okay, so what you're going to do from there. There's no kill. You either do this or not do it at all. Okay. Secondly, is that I think people fear what they don't know. So what we try to do is educate people to understand. We're not saying that because the Hawaiian eat it, it's okay. We didn't say that. It's not. It seems like we irresponsible. We say that there's no scientific evidence that it is harmful to human. That's what we're saying, and we try. Even now, we try to provide all this evidence that all was okay. As we do it, and we also try to do even more than what the Hawaiian did. There's some group already trying to do the protein study, so we try to actually even further demonstrate it is safe, and it's up to the public, up to the people, what do they think. Because as you already noticed, we come from the government organization. It actually make profit on us at the moment, and probably the whole mood. But we do it because it's trouble or problems that we could solve by using the technology that we have. That's why we do it. Thank you.
Okay, Alan, please.
My name is Ellen Kitson. I'm from Australia, and I certainly have enjoyed eating papaya every morning with my breakfast and here. Just two questions. Have you developed any cultivars that carry both of the gene changes, or do you intend to? That's one question. And the other was, you mentioned that the aphids are the vector for transmission of the virus. Have you done any studies looking at the aphid response to the transgenic papaya?
For second question, we do have put them in the biosafety project, which is the next step of this kind of, maybe Dr. Vishai will give you the detailed idea. But we do concern about the gene, horizontal gene transfer to the microbe or to the other insect that live with the papaya, in the papaya field or something like you say. And for the first question is?
The answer is no, we don't have, but there was many reasons. First is that the party confliction, the frustrations, because the technology of both sides come from different companies. We won't mention the name. So we were thinking that maybe if we can try to start with the maybe not resistant, the tolerant variety that maybe give us a better idea, but it hasn't been done at the moment.
Thank you. Strata next, and then
Thank you for your presentation. The science part, I must admit, molecular biology is very exciting. Now the reality of the money part. Who holds the patent of GM papaya? University, state, or some firm? Number one. If the university or the lab or state holds the firm, are you in the process of university-industry partnership in the future? This is number one. Number two is that when you say that to increase the shelf life by 5 days, you think in terms of that the GM papaya will be there in the supermarket. Well, I mean in terms of Thailand maybe it is fine, but let's move from the molecular biology field into the position of a villager in some part of the world, and if you say that what's the use of doing something which has been there and thinking that what is the use, not in terms of science, but in terms of the whole history of agriculture and the food production. Kind of lay question, but I will urge you to think in terms of a lay villager and wondering and looking around the science of agricultural scientists who are working on that. What will be your comment on that?
Okay. What's the first question? The pattern, okay. The pattern of all the technology probably, it's the same situation as other country like in Malaysia, our neighbors, and all that. So you probably all know all the big companies that all the same. But at the moment we did it on the research scale, and there was some sort of agreement that it was okay at the research scale. And as for who owns it, because we are the government, we work for the government, so our institutes basically own everything, we didn't own everything. Okay, that's the first question. And I'm not quite sure whether I understand the second question very well. Maybe when you mentioned about something about the supermarket and the value of the papaya, is that right?
If you imagine from the perspective of a lay village person in the countryside, what do you think their perspective is on the GM papayas?
Oh, okay. Again, I have to say I answer on the Thailand perspective, who grows them first. Okay, in Thailand, you got first the backyard papaya, everyone grows them. So whether they can sell it or not, doesn't matter, because you eat them anyway. The rest for birds or whatever. Secondly, it's someone that really grown them to sell. Okay, so if there's something that you can, okay, not actually increase the yield, but you can keep harvest them for longer, more than 1 year, or because if you have PRSV, you can't harvest them at all. That's really something, and you might. I'm not trying to talking about make millions and millions from papaya, and not in that scale, but we were talking about more of a stable income. Even that is a good start for us. That's why we think that it's be good for the farmers. And what I'm trying to point out as that slice of the advantage as a usage of papaya is that you not have to just sell them in the market, and if it's rot, it's rot. I'm just saying that it's got so many applications. You don't have to sell them fresh all the time. And even now, some people already started stove and all that. Some of you probably already buy some from the famous British brand name. It's got one line just for papaya products. It's like that. Thanks.
Thank you. So last comment from last question.
Thank you. My name is Al Mamun. I am from Bangladesh. I would like to raise one issue, that is food safety. You have mentioned this GM, there is no evidence regarding this GM papaya, these are harmful to human health. But my question is there any study which you have performed on this GM papaya and human health? Is this GM papaya totally safe? Is there any studies which have proved this GM papaya, these are not harmful on human health? Because there are so many debates on GM foods and food safety.
I think we should wait for Dr. Vishai, because that topic will be explored later. But yeah, maybe we should wait for it.
But it's on the process. I mean the food safety concern. I think we have the project that some staff of Biotech and some of FDA of Thailand cooperate and will make the report and will be released later on. But we will do our concern both of biosafety and food safety. And for sure that the government by the action of FDA will do this according to our staff on the biotech side as well.
Okay, well, thank you very much for the presentations, and I think we have some more technical questions later when we come after I think we'll have the next two papers, and then we'll have again a session of question and discussion on the biosafety aspects. I'd like to ask Dr. Ushai Kosatratana to talk about the biosafety study of GM papaya in Thailand. While he's coming to the stage, I'll just point out that although food biosafety is a good question for study, these similar papayas are eaten from supermarkets in the United States and other countries for a number of years without such studies. So already, if you go to the shops in some countries, you've been able to eat these for a long time. Thank you.
Thank you very much. My name is Vichai Kosilat. I'm a staff member of the Faculty of Agriculture and Department of Plant Authority at Samang Family here. My topic will be concerning on the biosafety that will follow up the Kanok 1 and Parisha work. I'd like to show you some picture of the papaya in Thailand. Thailand may be ranking around the fourth of the world on the papaya production. We produce about 400,000 tons per year, and on the about 300,000 hectares. And you may really not know that our 300,000 hectares where the papaya grows. It's very sad story to tell you the real story, because you will never see when you drive right along the street, you will never see papaya plantation in Thailand. But the two plantation will be in the forest. So the farmer go out there to deforestation and grow papaya. That's the papaya comes from. Okay, why? Because the main thing is papaya used to be grown at the backyard like this. Every house have their own papaya. And very easy, you see the Thai style. You can just, grab the papaya from the tree and make the papaya salad. Very easily, that is in Thai lifestyle in the Northeastern. So, but the problem is come out in around 1975, the papaya import come in. And so the way of life is changing. So they export from the papaya will export from the local area to the northeastern part of Thailand. That economic in the local of northeastern is changing also. You can see that it domino effect also. And from that we try very hard. Since 1975, I started work on crop protection by like a vaccine to do that, to produce the vaccine and rubbing on the leaves and let the poor farmer to grow. However, that thing is not really get the full success because as Parisha mentioned, it have two houses. One is on the cucurbit, another one on the papaya. And Thailand grow papaya and cucurbit in the same place. So you looking the papaya out, cucurbit still out of papaya in spot virus. That's why it's still in that circle, in the bad circle. So
Once in 1986, when the first paper came out in Science by the group of Roger BC Lab, where I have a chance to go there to learn how to make the papaya transformation. So we get back and do that. Start in around 1989. We start to do transformation thing. I think we do it before Hawaii, in fact. And so that's the way that we like to point out that's why, due to we didn't have a resistant variety. Papaya bring to Thailand about 200 years in the beginning of the Chakri dynasty, around 200 years. And no other method to control, because the way that aphids transmitted usually short time, around 10-20 seconds. You didn't have any pesticide, any biocontrol agent to kill the insect, while they can still transfer the virus from plant to plant. That makes it very difficult to control this disease. That's why worldwide this virus is number one of the papaya diseases. It happens worldwide. Compared to other disease, you can see it only sporadic in this country, in those countries, not like ring spot. Ring spot you can find everywhere in the world due to this nature. And you can see the poor plant like this, farmers put their own money on and get nothing out from the plant. Almost nothing, I can say. If you grow 1 month old papaya, and while this virus get in, you will get nothing. And how you gonna do this solve this problem with the poor farmer? I like to ask all of you. That's why we look into the thing that we can help them. And in order that we start doing the Transgenic papaya, and now we are under around the 4th generation of the Transgenic papaya. That's why we need to come in to concerning about the risk assessment of papaya crops that might have some risk to the environment. So two things that we want to really look to. We want to determine that really change from our papaya or not. In fact, I cannot say our papaya, because papaya from Mexico, but we borrow them. And we also determine the impact to the environment. So it's step by step. We really don't think that our papaya spot resistant variety will go out to the market tomorrow. We didn't think like that. We just want our society really have scientific mind in the mind. Not only someone come in and say, hey, papaya is the Frankenstein food, and believe them, and and our society has been painted like that way, all the time. I feel very, very, very sad in my mind. That's why I try to push this project out. This project, in fact, just starting a few months ago. Because we just really want to really see that on the scientific side, what really happened. Why Hawaiians have taken them for 5 years already, and Thai, what will happen in the scientific standpoint. That's the thing that I like to do. So, at the standard protocol, we will compare the agronomic characteristics to see the morphology, to see the growth, to see the yield, see the viability of the plant, how the pollen can be transferred to other plant or not. So we look on the biology of the plant, compare among transgenic and non-transgenic one. I will look on the gene stability. That means if the plant grow to the next generation, it will be still resistant or not. If it's not, why we need to do it? It's no point to do it. We will waste our time. So we look on that. And we will see on the horizontal gene transfer that might be transfer the gene to the microbe, to the another crop, to make new virus that all people fear. I'm a plant pathologist by training, so I really like to see also that it really happened or not. People say, might have new virus come out, but so far, it's no evidence show that. Also, we will look on the beneficial effect for the main thing, because as Richard mentioned before, we have several insects that will be associated with the papaya plant that I will be talk later. So our test plan will be the plan that we got from one lab will be put into our test and work under the greenhouse like this, around 10 meters wide and about 20 meters long and tall, about 3.5 meters. We will work in this greenhouse and we will use monitoring or everything that in the greenhouse, for example, light, temperature, humidity, and soil moisture content, and we will compare the statistically among these two plants, and we will look on the viability on the pollen like this, on the staining, and on the germination, and as mentioned before, we look on the gene that we incorporate into the plant, and it will stay there or not. And we also try to do another thing, like to see how this GM plant attract another microbe or not. For example, we do the satellite pot like this. We grow the normal plant here, we grow the GM here, we grow the non-GM here, and to see how the microbe from soil will move. And in this way, we hope we can learn more about it. It just can, that by microbe, it can, our transgenic plant more attract the microbe or repel the microbe more than the work that has been proposed before. Only take a look on the population of the microbe, on the other thing, but we try more on that. And also to the bacterial identification truly our study. And after that, crops, we will grow our follow crops. We should dicot, monocot, and tuber crop to be represented and to see what will happen after we grow in the transgenic pot. What will change the gene flow or not will be studied under the greenhouse. And for the transgenic, for the insect, as I mentioned, we will look on the insect that associated with the papaya. For example, papaya, the spider mite, trip, mealybug, aphid. In the first phase, we will pay more attention to the less spider mite. We will, due to the less spider mite, it might be have the right chain with the predator mite. So in this case, we will study on the predator mite, that this mite that feed on the GM crops will have the effect anything, or the light table on the predator mite. And we will also look on the growth and the population dynamic of the aphid in order to see that it happens to aphid or not. Because normally papaya is not a host for aphid. The aphid should come in and probing on the papaya and shoot or inject the virus into the papaya. After that, papaya, not the host, they will withdraw the silent and go to another plant because the every feed of searching the food by the color of the plant. Everything that green, that yellow, the every will land it and probing, and after that they go. If it's not their own host plant, they will be gone. And that's why we should let spider mite to study first, and after that we will go to more another insect like trip and aphid. And we expect that our outcome will be we have a comparative data concerning to the biosafety plan to see that we should go further step or not. And also the scientific evidence will be answered to the public concern. And lastly, that I have been telling you before, that we really want this finding to educate our community to think in the term of science. Also will deal on, I cannot deal to the policy maker because they give money. They can cut our money also. And we hope this information will send them and tell them we should go on the GM crop or not. Not only by outside organization come in to the country and say Thailand should not go GM papaya. What happened to this country? If we're not based on the science base, we're not concerned to the public acceptance, we're not concerned to the other people. You just come in and blocking our tree. I feel very bad when that time happened. That almost a year ago. Just same like a 9/11, same thing. So with that, I like to stop here, and I'm willing to really share information with you on this thing. Thank you very much.
Thank you. Thank you very much. So I think it's best we also hear from Pahol, please, on his paper, and then take questions together. And this will develop our discussion. So, Pahol Kosayamchin is from Mahadol University in Thailand. And he'll talk on the Transgenic Thai papaya story and give also some background on the social aspects and discussions in this country. And then we'll have discussion together.
Okay, good morning, ladies and gentlemen. Today I'm going to talk about the story of Transgenic Thai papaya, which is a milestone of Thailand toward a biotech crop country. Well, first of all, I would like to thank to Dr. Maser for the invitation and the opportunity that I have to speak to you today. For some of you who might not have seen papaya plant before, but this is a fruiting papaya plant. Papaya is a tropical plant grown in the tropics and subtropics, including Thailand. The story of Transgenic Thai papaya, however, started in the United States. Well, here is the big island of the US state of Hawaii. But over there, growing papaya is a big business, second to just pineapple. The major production area of papaya is on the big island of Hawaii, especially in the Puna area. But in the year 1992, most of the land in the Puna area were devoted to growing papaya, and papaya was the major income source for the local people. Later in 1992, papaya ring spot virus causes the ring spot disease had arrived to the area, and the characteristic ring spots could be found on the fruits and the stem of the infected plant, and this is where it got its name from. 2 years later, from the very same field, The infestation of the papaya ring spot virus almost wiped out the papaya industry. Since there is no cure for virus disease in plants, to find an alternative to control the virus in papaya, a group of researchers at the University of Hawaii and Cornell University worked together to engineer a virus-resistant papaya. Well, the resistance mechanism had been identified as the post-transcriptional gene silencing, which is also known as the molecular immune system. In the year 1997, the transgenic papaya was tested under field conditions. In this photograph, you can see that the dark green area in the middle here, these are the transgenic papaya, whereas the yellow rims around it, these are the non-transgenic papaya. Well, let's take a closer look at this corner where the red circle appears. Obviously, on the left, these are the non-transgenic papaya. It's severely infected by the ring spot virus, whereas on the right, these are the transgenic papaya, which looks healthy and withstand the infection very well. This photograph was taken a year after the deregulation of transgenic papaya from a commercial field. Once again, the papaya farmers reclaimed their lands for papaya production. This has not been just a success to the papaya production, but also a success to the farmers who had lost their jobs or who had no other choice but working in different fields like driving a truck, taxi, or even giving cleaning services. When we take a look at the papaya production, after the virus infestation, the papaya production reduced to almost about half. By 1998, the transgenic papaya was deregulated, and the transgenic papaya was the first genetically engineered fruit crop in the market. From there, the production started to increase. Now moving back from the United States to Thailand, the success of the transgenic papaya in the US has been well recognized all over the world. At this time, Thailand experienced an outbreak of papaya ring spot virus in the major papaya growing areas, which are mainly in the northeastern part of the country. At this time, without any effective virus control measure, the Thailand Department of Agriculture called for help from Dr. Gonsalves, who was the leader of the Transgenic Papaya project in the United States. In 1995, the Ministry of Agriculture sent one scientist with papaya seeds from Thailand to learn the technology and to transform the Thai papaya at Cornell University, New York. Then the transgenic Thai papaya were engineered. Because this was the first time for Thailand to work with the living modified organisms, a committee was set up to study the safety issues concerning transgenic papaya, although Thailand is still to be a member of a party of the convention. The committee has been following the guidelines on the Convention on Biological Diversity in a precautionary approach. Environmental risk assessment has been set to follow the Cartagena protocols on their safety, while the health risk assessment has been set to follow the Codex Alimentarius issued by the FAO. Well, when conducting the risk assessment experiment at the step of the risk identifications, we need to take into consideration that perceivable risk is not equal to the actual risk. After the greenhouse experiment in the year 2000, the test was done under contained field conditions. Again, you can see that the non-transgenic plant on the left were severely infected by the virus, whereas on the right, these are the transgenic papaya which look healthy and withstand the infection very well. 4 years later, in August 2004, there was a group of people invading Konkan Agricultural Station, which is the location of our experimental field for transgenic papaya. Both national and international media were present when the protesters, who identified themselves as members of Greenpeace, collecting transgenic type papaya fruits.